And we are back with another mechanics video. Today we're going to be looking at a second example on kinematics, and as usual this is going to come from a Cambridge past paper, and we're going to be looking at May-June 2003 paper 4 number 7, and it starts off with part I, which says a tractor A starts from rest and travels along a straight road for 500 seconds. The velocity time graph for the journey is shown above. This graph consists of three straight line segments, which is 1, 2, 3. Find the distance traveled by A. Well, that's quite simple. The distance is equal to the area under the velocity time graph. So it's simply the area of the triangle plus the area of this triangle plus the area of this triangle plus the area of this trapezium plus the area of this triangle. So the area of the two triangles plus the area of the trapezium gives us the distance traveled by A. So that's going to be the distance traveled by A. And then the initial acceleration of A. The initial acceleration of A is the acceleration when time t is equal to 0. So the acceleration over here. But because this is a straight line, we know that the acceleration here is the same as the acceleration there, it's the same as the acceleration there, it's the same as the acceleration here. So it's basically just the acceleration of this entire straight line here, because it's constant, and we know that the acceleration in a velocity time graph is the gradient of the graph. So it's going to be this 4.8 minus 0 over 100 minus 0. So you already know how to find gradients. I'm not going to be stressing too much about that. So we know that the acceleration is equal to the gradient, which is going to be equal to 4.8 over 100, and that is going to give us 0.048 meters per second squared. So that's going to be the acceleration of the car. That's going to be the initial acceleration, which is the acceleration at time t is equal to 0. Then it says another tractor B starts from rest at the same instant as A. So if A started at t is equal to 0, then B is also going to start at t is equal to 0, because it starts at the same instant as A and travels along the same road for 500 seconds. Its velocity t seconds after starting is 0.06 t minus 0.00012 t squared meters per second. Find how much greater B's initial acceleration is than A's. What does this mean? We find the acceleration of B, the initial acceleration of B. We find the initial acceleration of air, of A, not air. We find the initial acceleration of A, we find the initial acceleration of B, and then we simply compare the two by how much is B's greater. Well, we have the initial acceleration of A as 0.048, which we calculated here. So now we just want to find the initial acceleration of B. So how do we do that? We've been given the velocity, so what's the acceleration? Well, this is where our calculus comes in. Because we know that acceleration is the rate of change of velocity. So basically differentiating the velocity is going to give us negative 3 over 12,500 t plus 0.06. So I'm not going to go into details on how to differentiate. You already know how to differentiate. If you've forgotten how to differentiate, I have a playlist in the Pure Math section on calculus. Go and watch those if you forgot how to differentiate. We're simply differentiating this function here. So that gives us the 0.06, and then double this by the 2, decrease the power by 1, and you're going to get this. So this is the function that is going to give us the acceleration of the tractor. So we differentiate the velocity function to get the acceleration function, because the acceleration is the rate of change of the velocity. So the initial acceleration of B, like I said, the initial acceleration is the acceleration when time t is equal to 0. So the acceleration when t is equal to 0 is basically going to be us plugging in t is equal to 0 over here, multiplied by 0 plus 0.06. This goes away, and we simply get 0.06 meters per second squared. So this is the initial acceleration of B, and this is the initial acceleration of A. So if we want to find out by how much is this greater than that, we're simply going to subtract the two. So therefore, we are simply going to say 0.06 minus 0.048, and that's going to give us 0.012. So therefore, the way you would answer this question is you would then say that the initial acceleration of B is greater than the initial acceleration of A by 0.012 meters per square second. The initial acceleration of B is greater than the initial acceleration of A by 0.012 meters per square second. That's how you would answer such a question. Then part 4 says how much further B has traveled than A at the instant when B's velocity reaches its maximum. So what do we need to do? The same concept applies like what we did in part 3. So let's find out how much has B traveled, how much has A traveled, and then the difference between the two is how much further B has traveled. So what distance has B traveled when its velocity reaches its maximum? What distance has A traveled when B's velocity reaches its maximum? So how do we know, where and when B reaches its maximum velocity? Now, this is where you need to think quite a little. Well, if I just move my thing over here, we know that the velocity of B is given by negative 0.00012 t squared plus 0.06 t. Okay? We know that this function here gives us the velocity of B. Now we want to find out when is the velocity maximum. Okay? Now, we're going to think outside the box a bit here. The method that I'm using here, it's not in the mark scheme, but, it is a pretty cool method. I mean, you could do this in a different way, but let's think outside the box a bit here. This function here gives us the velocity of B. But what do you notice about this function? This function is a parabola. It's a quadratic function. In other words, if you were going to sketch the graph of the velocity against the time, you would get a parabola, which is going to have a maximum point. Okay? You would have a parabola which is going to have a maximum point. You would have a graph like this, and you would have this one here as your maximum point. Now, the maximum point is going to be the maximum velocity, because you're plotting a graph of v against t. So at the maximum point, you know that your velocity is going to be a maximum. So this point here is going to represent the point of maximum velocity. So in other words, the turning point of this parabola here, the reason it's a parabola is because t squared. T and then t squared, so that makes it a parabola. So the turning point or the stationary point or the maximum point of this parabola is going to represent the maximum velocity. Why are we interested in the maximum velocity? Because the question said when B's velocity reaches its maximum. So how do we find the stationary point of a parabola? I have a playlist on this in Pure Maths. If you've forgotten how to do that, go check out the playlist. But basically there are two ways. The first one is whenever you want to find the maximum point or the minimum point of a parabola, you simply complete the square. The second method is you differentiate this, you equate it to 0, you find the value of t and yada yada yada. But I'm going to go for the easier way, which is to complete the square. So I'm simply going to complete the square for this function here, and that is going to give me VB is equal to negative 0.00012 multiplied by t minus 250 squared plus 7.5. So what I get when I complete the square for this parabola. You might be wondering, how did I complete the square so fast? Well, I have a playlist. on completing the square, and I show you a very simple and quick method on how you can do this thing in one line. Go and watch those videos if you're interested in knowing how I completed the square very fast. Um, for some of you, this may be difficult, so you might want to just do the other method of differentiating this first, equating to 0, and then finding the value of t that makes that 0, and so on and so forth. But completing the square is very easy, and if you want to know how I did this extremely fast, make sure you check out my playlist on completing the square. So I know therefore that my maximum point is therefore going to be 250, 7.5, where this 250 here, is my time. Oops, okay. Where this 250 here is my time, and this 7.5 here is my velocity. Because like I said, I'm plotting a graph of velocity against time, and I'm going to get a parabola. So this maximum point here, you know, this here is my 250. Okay, this here is my 250, and then here is my 7.5. This here is my 7.5. Okay, this is my 7.5. So this is my t is equal to 250, which is this one. And then this is my v is equal to 7.5. So if I plot a graph of v against t, I get a parabola, and the maximum point is going to be 250, 7.5, where this 7.5 is the velocity, and this 250 is the time. So what does that tell me? It tells me that my maximum velocity is going to be 7.5 meters per second, and that happens when t is equal to 250 seconds. So my maximum velocity is 7.5 meters per second, and that happens when my time is going to be 250 seconds. In other words, when this tractor is traveling, it's going to reach its maximum velocity when the time t is equal to 250 seconds. So now I want to find out, then what is the distance that b has traveled when t is equal to 250 seconds? Because remember, my goal here is to ask myself, how much of a distance has the tractor b traveled when it has reached its maximum velocity? And we've just deduced here that b reaches its maximum velocity when the time is 250 seconds. So how much distance has b traveled when t is equal to 250 seconds? Well, I know that the velocity of my b is negative 0.00012 t squared plus 0.06 t, and I know that this velocity here of b is the rate of change of the displacement of b with respect to time. So the velocity is rate of change of displacement. So what that tells me is, therefore, that my displacement of b is going to be the integral of the velocity of b with respect to time. So basically, I'm going to integrate this, and integrating this function here, integrating this function is going to give me the displacement of b is equal to 3 over 100 t squared minus 1 over 25,000 t cubed. So when I integrate my velocity function, I'm going to get my displacement. So my displacement is going to be 3 over 100 t squared minus 1 over 25,000 t cubed. So this function here is going to give me the displacement of the tractor at a particular time. So now I want to find out what's the displacement when the time is equal to 250 seconds. So basically, I'm going to plug this in, 3 over 100 times 250 squared minus 1 over 25,000 multiplied by 250 cubed. And if I do that, I'm going to get my distance as being 1,250 meters. What does that tell me? It tells me that when the tractor has reached its maximum velocity at t is equal to 250, it would have traveled 1,250 meters. So this is going to be the distance that the truck has covered. So now I need to find out, well, what's the distance that A would have traveled when t is equal to 250? Well, 250 is somewhere here. So I need to find the distance up to here. Well, how do I find the distance up to here? It's going to be the area underneath this triangle plus the area of the trapezium up to 250. So now I need to get this point here. I need to ask myself, what's going to be the velocity of the tractor of A when t is equal to 250? Well, how do I do that? Well, the way we're going to do this, therefore, is to find out the velocity, of the tractor A at this point here. I'm going to find out the velocity of the tractor A at this particular point here. How do I do this? Well, I see that this line is a straight line, so I know that the gradient of this line is constant. The gradient of this line is constant. So let me find the gradient of this line. 1.2 minus 4.8 over 300 minus 100. So I know that the gradient is going to be 7.2 minus 4.8 over 300 minus 100. And I'm going to get 0.012. So in other words, 0.012 is the gradient of this line. So if I pick this point and that point that I'm looking for, which is 250 comma some velocity, then I should get 0.012. So if I call that velocity x, then I know that x minus 4.8 over 250 minus 100 should give me 0.012. Should give me 0.012. And that means that my x is going to be 6.6 meters per second. If you solve for x, you're going to get 6.6 meters per second. So therefore, I'm going to have point 250, comma 6.6, which is going to be here. So now I can easily find the area of that trapezium. So the area of this triangle is 240. A half multiplied by 100 multiplied by 4.8, that's 240. So therefore, I know that the distance of A is going to be 240 plus the area of the trapezium, which is half of 6.6 plus 4.8 multiplied 6.6 plus 4.8 multiplied by 150. Why am I saying 150? Because if this is equal to 250, then that 250 minus 100 gives me the 150. In other words, going from here to that 250 is 150, because remember, my trapezium is going to look like that. And that is going to give me 1095 meters. Oops. That's going to give me 1095 meters. So A would have traveled 1095 meters and B would have traveled 1250 meters. So the difference between the distances 1250 minus 1095, that's going to give me 155 meters. So what does that tell me? It tells me that when B reaches its maximum velocity, it would have traveled 155 meters more than A. And let's look at the answer here. 155 meters, and every other answer is also correct, 0.048, and so on and so forth. So anyway, that brings us to the end of this video on answering this particular question. If you enjoyed the video, like the video, leave a comment below, share the video, and until next time.